this tutorial, we're going to learn how to test if a network is viable using the angular segment analysis. So this is a continuum of the previous tutorial where we installed Depthmap, and then we created a segment analysis to evaluate the connectivity of a network. So now we want to test how viable the network is from a specific point. So to do this, what we can do is select the area that we want to test from. So you can do that by clicking and dragging, and then it will highlight the segment in yellow. So you do want to be on the little arrow icon here. So click and drag, and then we'll head over to Tools, Segment, Step Depth. And here you've got three options. You've got the angular step, the topological step, and then the metric step. So the angular step, that shows how many road segments it has to get to every stop. Oh, for every step, actually, sorry, not stop, to get to every step. And then the topological step shows you the number of directional changes of streets from the chosen street, so that our chosen segment. And then the metric step shows you the pure metric value of street network from the chosen street. So we'll just actually only test out the angular and the metric for this tutorial. So select it, and then it will evaluate. So as you can see, it's evaluated it, and it's blue in the closest areas, and then it will gradually change to orange and then red, as you can see here. So a good way to actually test if a specific segment is connected to your network or not is if it ends up being grey. So these areas are not connected to the network at all. So the next one, what we'll do is we'll test out the metric. So none of them are showing out, which means I haven't highlighted the segment. So it was this guy over here. Go back to Tools, Segment, Step Depth, and Metric. And then it will evaluate that for us. There we go, that should be done. So on the attributes list, you can see that both of them have been added. So our next step is we want to evaluate or run a segment analysis or an angular step analysis. So to do that, we go back into Tools, Segment, and it's the first one that you see, Run Angular Segment Analysis. So what this does is it runs an evaluation from that segment to all the other segments. So we can do that. And then it will bring up this dialog. So the tulip analysis, sorry, here, the smaller the value, the less refined the analysis is, but the bigger the value, the longer it will take for the evaluation to happen. So I'm going to leave it as 128, which is what I did previously, but it can go as high as 1024. We also want to include the betweenness, includes choice, which is, it shows you the busyness of each segment. And then under radius type, we want the metric. So we want the metric, which allows us to add more attributes or different modes of transport. So here we can include where pedestrians, so that's about 100 or 800 meter radius. And then we can add cyclists, which would be 2,500. Then bigger cycle networks, which would be 5,000, and then road networks, 25,000 kilometers, and then N means the whole network. And then under weighted values, we want to include the weighted values of segment length. And then select OK once we're done. Okay, so there's a space in here somewhere, so no space. So select OK, and it will run the analysis for us. This might take a while. You can use CAD or Rhino to edit your DXF file, and then you can also import that as well. And you can compare and contrast like the existing conditions with the ones that you've just edited to see if it's if your network is more viable or more pedestrian friendly, or yeah, just compare and contrast those two. There we go, so that's all done. It's evaluated that for us. Sometimes it doesn't show up in your attributes table, so what you have to do is unselect the segment map, and then when you select it again, it'll show you all the new attributes that you've just added. So there we go. So you can see that there's choice values or there's integration values. So the choice is how busy the whole network of the road is, and then the integration is how central a road is. So you can see the red areas are more well integrated than the blues. You will see that both the choice value and the integration values without the numbers, so these ones, and they are the N value, which represents the whole network. And then you can see the ones that we've added. So for the pedestrians, and then we've got the cyclists as well. And then we've got the huge, or the road networks. If you go, let's see, let's find the pedestrian, or let's go choice, 800. So this shows you, it represents how the pedestrians have to travel to get to, or how far the pedestrians have to travel to get to public transport. So this area was where Dandenong Station is, and then that's like the 800 meter radius. And then we've also got for the choice, we've got the 25,000. They're a bit annoying because they're divided up. And then you've got the bigger cycle networks, and then you've got the roads as well. So the 2,500 and the 5,000. So the 5,000 bigger cycle networks. These are where cycling is more prominent or for longer distance, and then again where cycling is still more prominent for shorter cycle distance. And then for the integration with no number, so that'll be, yeah, as I said before, the N value, which is the whole network. And then, yeah, so the red areas is where they're well integrated. And then you can also check pedestrian integration as well. So N value for pedestrian is, there we go, not N value, the integration value for pedestrians. So you can see here is where the train station is. And then you can see how well integrated it is, which is not very well integrated. These are where all the residential areas are, so it's a bit difficult for them to get to the train station here. So if you were to update or this network, maybe you'd add a train station here so that it would be easier for these residents to get, or workers to get to the train station. if the color, so if the color of the map appears a little bit dull, you can also adjust the color mode. So you can do that going to Windows and then color range. So anything, you can adjust the slider here. So that means anything that is below 35 will be in blue, and anything above 280 will be red. So you can balance it out a bit and apply to see the changes. Maybe we'll put this back down and take this back up. And then close once you're happy with that. Oh, actually, you can also change the color mode if you want. And apply. That looks pretty cool. Or you could just keep it simple. Yeah, that's quite like grayscale, but we'll just go back to 3 color mode. And then close that. Now we can export. So file or edit, you can export the screen. It's a bit slow. And then you can export as a EPS file, which is a vector-based file that can be read in Illustrator, but yeah, there's no scale on these. So that's a downside of that one. So if you want to export to ESV file, find the destination that you want to save it to, make a name for it, and then save it. But I'm not going to save this one, but what I'll show you how to do is also save the file as MIF file so that you can import it into QGIS for later. And to do that, you can go to Map, and then we want to export it this time and export map. And head over to the destination you want to save it to. Actually, how to. And then go down here, we've got map info file, so MIF file. And then we can name it. Two videos, actually don't want to save it to. All right, so we can save it into here. Save. And so yeah, with the MIF file, you can import it into QGIS. So that's it for this tutorial. So overall, you've seen how you can use Depthmap to evaluate a network from a specific location to see how connected that specific area is to the rest of the network. And that's it.